Okay, so in this video we'll wrap up part D. An investigator uses the tangent line approximation to P of t at t equals 0 as a model for the amount of pollutant in the lake. At what time t does this model predict that the lake becomes safe? So I'm going to bring back up the calculator for a second and take a look at the graph. Okay, so we want to find the tangent to the graph, the tangent line to the graph at t equals 0. And we're going to use that tangent line to approximate the function p of t. So that tangent line is going to approximate the amount of pollution that's in the lake at any time t, and we want to find out at what time does that pollution, according to that approximation, fall below 40 gallons. Okay, so I put the calculator away. Let me think about what is it that I need in order to find an equation of a tangent line. Well, I need a slope and I need a point. And I know that we're going to do this at time t equals 0, so my point is 0, 50. And I've already identified that point above. Now, what I want is p prime of 0 to be the slope at that point. And for that, all I need to do is go back to my function. If I were to plug in t equals 0, if you look at the function p prime of t there, plug in t equals 0, the whole exponent is going to become 0. E to the 0 is just 1, and so it's 1 minus 3, which is negative 2. So I don't even need to go back to the calculator to do this. Now I'm ready to begin. The equation of the tangent line will just be a linear equation, and it's y minus y1 in point slope form. Y minus y1 is m is equal to m times x minus x sub 1. So y minus 50, which is my y sub 1 value, equals negative 2 x minus 0, or y equals negative 2x plus 50. I want to find out when that is going to hit 40. So I have 40 is equal to negative 2x plus 50. I subtract the 50 over. Negative 10 is equal to negative 2x. And so x is 5, or actually in this case t is equal to 5. So that model, using the equation of the tangent line at t equals 0 to model p of t, that particular model would approximate that by time t equals 5, or by the 5th day, the amount of pollution in the lake would fall to a satisfactory level, or a safe level, and the lake would be safe. And so I just write my conclusion. The model predicts that the lake will be safe on the 5th day, or t equals 5. Alright, so that should do it for this problem, and in the next video we'll go on to problem number 3.